Okay. All right. Can everybody see my screen? Just give me a thumbs up. All right. Okay, so I'll get started on class for today. So we weren't able to cover everything that I was talking about in class 3. So I'll get started on that first. Okay, so last time we covered synthetic division, and now we're going to just quickly go over the remainder theorem and the other parts of part 3 of class 3, and then we'll move on to the other parts. Okay, so for the remainder theorem, this is just a quick way for you to find the remainder of an equation given when the given function is divided by x minus k. Okay, so pretty simply put it, you just plug in k for x in the function, and then you just solve and simplify. So here are some examples. So for I'll do the first one. So for the first one, f of x is equal to 2x to the third minus 5x squared minus 6x plus 9. So you just find the remainder by then you have k equals 2. So simply put it, you just put 2 into, you plug 2 in, so it would be 2 times 2x cubed minus 5 times 2x 2 squared minus 6 times 2 plus 9, and then that it would be the remainder. So that's just a pretty quick and easy way to find to deduct the remainder if you ever came across a problem that said something like determine the remainder determine the remainder with the given problem. So for those of you that just joined, we're just going over the end half of class 3 because we weren't able to get to all of it last class. And we're currently talking about the remainder theorem. So I would say just take about 3 minutes, just work on problems 1, 2, 3, and 4 very quickly. And because I'm trying to get 2 lessons done in one class's time, well, 1.5 lessons done in 1 class period of time. Just do, I would say, numbers 2, 3, and 4 using the remainder theorem, and then once you're done, just put the answers in the chat box. Again, just to find the remainder of this function when divided by x minus k, you just plug in whatever value k is into the x spot in the equation, and then that is your remainder. Yeah, and then we'll just take about 1 more minute. It's fine if you don't finish all of them. Just at the end of the 1 minute, just put whatever answers you've gotten just put them into the chat box, and then I'll go over the questions. All right, just put whatever answers you've gotten into the chat box, and then I'll go over numbers 1, 2, 3, and 4. Okay, so for number 1, you would get the remainder of -7. Next, for number 2, you would get remainder of 1. For number 3, you would get remainder of -15. And then for number 4, you would get a remainder of -9. Again, how you would solve these problems, you would just plug in k for x. So for example, if we were to take a look at number 2, f of x equals 3x to the 4th minus 2x cubed minus 3x squared plus 2x plus 1. And then using k, when it is divided by the factor of x minus 1, 1 being k, you just plug it in. So you would get 3 minus 2 minus 3 plus 2 plus 1, and then you would get 1 as the answer. So this is just a very quick and easy way for you to figure out the remainder of a polynomial when it is divided by x minus k. All right, moving along. This I won't have you guys do. I'll just quickly go over it. So these are just the different ways of factoring. You can factor by grouping, via grouping the first two together, 15n minus 15n cubed plus 10n squared, and then 12n plus 8. You take out the 5n squared in this for the first one, and you get 5n squared times 3n plus 2. And then you would take out 4 for this on this side, and then you would get 3n plus 2, and then you would group it together, and then you get the factor. Factoring polynomials in quadratic form, you would have to set when you see it something like this, you would have to set it to u squared equals x. So then you would get a very nice quadratic equation. So if u squared equals x, you would get x squared minus 3x minus 10. And then that is a much nicer problem for you to factor and kind of move around. Just remember at the end of the equation, after you factor it, that u squared does equal x, and then to further solve for u instead of just leaving it in the form of x. Next, perfect square trinomials. Just using the equation a squared plus 2ab plus b squared, you'll be able to pretty handily figure out how to factor it. So for this, 25v squared, a in this scenario would be 5v, sorry, and then 2ab. So in this case, and then plus b squared, so b would be 4. So these are just a lot of different scenarios, different cases on factoring and how you would factor. Okay. And then next, factoring, continued the sum and factor with the sum and difference of cubes. You pretty straightforward. You would use these two formulas. A cubed minus b cubed would equal to a minus b times a squared plus ab plus b squared. And then a cubed plus b cubed would equal to a plus b times a squared minus ab plus b squared. Very small discrepancy between the two. It's just where the minus sign is placed. But this small discrepancy can lead to a pretty big result difference in the equation, as you can see. And then lastly, we have factor with the difference of squares. So a squared minus b squared is equal to a plus b times a minus b. And then, so for example, 16m squared minus 9 would equal to 4m plus 3 times 4n minus 3. All right, and that is the end of the third class that we just quickly ran through. If you have any questions about that, or if I went through it too fast, just feel free to put it in the chat box and I can answer your questions. This slideshow, this presentation is also on Google Classroom. So if you can always refer back to it after class. Okay, now time for class 4 presentation. Okay, so agenda of today's class, I will try to get through to everything, but we might be a bit short on time. So we're just so homework questions. If you had any questions about class 3's homework, we'll review of imaginary numbers, what they are, defining zeros and finding zeros, conjugates, writing polynomials, factoring and solving polynomials, binomial expansion, factorials, binomial theorem, and then wrap up and questions. Most of the bulk of what you will learn will probably be in the first half. The binomial expansion, it's mainly just formulas and probably a bit of review as well. Okay, so does anyone have any questions related to homework or just questions in general? Okay, I do not see any questions on my end, so I will keep moving along. This is just a meme that I found on the internet for a review of imaginary numbers. So he is saying there is no Easter Bunny, there is no Tooth Fairy, and there is no factor of x squared plus 9. But now that we've learned imaginary numbers, there actually is. And then you can factor x squared plus 9 into x plus 3i times x minus 3i. Just to review, I equals the square root of -1. So when you multiply it out, you get x squared and minus 3xi plus 3xi. Those two cancel out, and then you get minus 9i squared. And then I squared would equal to -1. So when you multiply that into -9, it would become +9. So voila, you get x squared plus 9. So when I don't know if your teachers ever said that, it was impossible to factor x squared plus 9, but well, now you know how to factor x squared plus 9 in any kind of positive polynomials. All right, quick review, moving along. All right, now we're going to talk about defining zeros. So what are zeros? Simply put it, zeros are just the solutions to function f of x, or it can just be any function. I just used f of x as an example. And then that when the zero is plugged into f of x is equal to 0. So this is, I think it might be a bit confusing at first, but when you do it, it becomes a lot more self-explanatory. So for example, in this function of f of x is equal to x minus 2 times x plus 3, the zeros in this equation would be 2 and -3, because when either of these numbers are plugged into the function, into the f slot, so when f of 2 would equal 0, and f of -3 would also equal 0, because when they are plugged in, either this would equal 0 or the first part would equal 0, turning the entire function into 0. So that is what zeros are. It says it in the name. It is just what, when you plug that number into the function is equal to 0. So other theorems or just useful things to know. A polynomial function can have no more zeros than its degree. So what that means is if you have something like, I'm just making this up, but like you have something like x to the 7th plus like 10x plus like 5 or something like that. There's probably a lot more numbers in the polynomial, but as you can see, the highest degree is 7. So the number of zeros that you have to this equation can be no more than 7. This is just a good way for you to check your work when you're taking a test, taking a quiz about the zeros. It is a good way to double check very quickly to see, if you're a bit short on time, you can look back and say, hey, did I, if it's the power of 7 and I have 8 or 9 zeros, I did something wrong, and I would need to look back and double check. So that's just a good way for you to look back on your work and double check. All right. And then we're going to talk about conjugates. So this is also a bit confusing at first, but it becomes very self-explanatory once you do a few problems. So conjugates, this is the irrational conjugates theorem. I'll just quickly read it. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that root b is irrational, meaning that it cannot be further simplified. So for example, b could be something like 5 or 15. So when it is square rooted, it can't be simplified any further. Like if, like for example, if b was 4, that wouldn't work because it could simplify to 2. And then if a plus b plus root b is a 0 of function f, then a minus b is also a 0 of function f. The same can be said if a and b were rational numbers such that I is imaginary. Remember, I is talking about root -1. So if a plus b of I is a 0 of f, then a minus b of I is also a 0 of f. Okay. And this is super important that when you're talking about conjugates, only irrational numbers, meaning numbers with square roots, or imaginary numbers, numbers with the letter I in it, have conjugates, the flip. The conjugate, it's pretty simple to understand. It's just you flip the middle symbol from plus to minus or minus to plus. But regular numbers like 2 or -2, they would not have a conjugate. It is just for numbers that are irrational or imaginary. Okay. So finding zeros. Now there are two ways to find zeros. One is through factoring, and the other is through graphing. Today I'm just going to cover factoring because graphing, it takes a lot of steps and processes to do that. And then also for graphing, you would typically need a graphing calculator. I have a NumWorks graphing calculator that I use. So that is just, most Algebra 2 teachers will require you to have a graphing calculator, but always double check with your teacher first. Some of them might provide you with graphing calculators. I'm not sure, but these graphing calculators, the one I have, and a lot of other graphing calculators, you can also use it when you're taking the SAT and a lot of other college entrance or just those kind of college exams. So definitely, if you do have to buy a graphing calculator later on in high school, make sure that double check on the websites to see which calculators are allowed when you take the SAT. So then you're kind of killing two birds with one stone. So that's just my quick tip. Okay. So finding zeros, how do you find zeros? So first, you got to fully factor, then you have to set each factor equal to 0, and then solve the variable in each equation. Okay. So I will go through, let me stop screen recording very quickly. Everybody can see my phone camera, correct? Just give me a thumbs up. Okay. All right, so as I said before, the number we are looking for, the number we are looking at is x cubed minus 8. Right. Can everybody see my writing just fine? Does anyone want me to zoom in more? Okay. So what do you do from this point on? Well, first you would have to factor. And second. And so how would you factor that? Well, from class 3, I quickly mentioned how to solve when you're dealing with cubes. And you would use that formula. So you would get x minus 2 times x squared plus 2x plus 4. right? You would factor x. So first you would factor x cubed minus 8 equals x minus 2 times x squared plus 2x plus 4. So that is step number 1, to factor your equation. And after you've checked that it is fully factored, you cannot factor x squared plus 2x plus 4 any further. You set each of these equations equal to 0. What I mean is you take this equation, x minus 2 equals 0, and then x squared plus 2x plus 4 equals 0. Because this is how you find zeros, right? Because when you're looking, a 0 is a number that when you plug it in for x in the function, it makes the function is equal to 0. So this one, very easy. You just get x is equal to 2. So that is your first 0 found. Next, this one is a bit more complicated. X squared plus 2x equals -4. You would move the -4 onto that side, and then you would find, you would use the formula of b over 2 squared to solve the problem. So b in this case is 2, so b over 2 squared is 1. So you would get x squared plus 2x plus 1 equals -3. Okay, makes sense. You would just add 1 to each side, and then there we go. You can finally factor it into x plus 1 squared equals -3. Right? Is everybody following? Just give me a thumbs up or like a yes in the chat, so I know like that no one's completely lost. Okay. All right. So moving from here, what you would do is remove the square, right? So you would have x plus 1 is equal to, now this is where you gotta be careful, plus or minus the square root of -3. Okay, this is very important. Make sure that you don't make any mistakes when this step, because I think a lot of people make the most mistakes when they're on that step. And the reason, of course, why it's plus or minus root -3 is when you square that, it can either be plus or positive or negative. And then last step, you just -1 on both sides. So you get x equals -1 plus or minus I root 3. Always remember to take out the I when it is applicable. Just take out I again is equal to root -1. So it just makes the equation look nicer, and your teachers will always want you to move the I out of the square root. So now this is the part where we can double check. So what is it? It is x to the power of 3, right? That is the highest degree that I see. So so we would want no more than 3 conjugates. Not conjugates, zeros. And from this, you can see that we have 1 0, 2 0, and 3 0. Remember the plus or minus, it can be either -1 minus I root 3 or -1 plus I root 3. So boom, we have 3 conjugates, the third degree, it all matches up. So, and you would write it using the fancy curly brackets. My curly brackets aren't the best looking right there, but -1, 3. And that would be your final answer, ladies and gentlemen. And this is what I was talking about when I was mentioning the conjugates. How, as you can see, how right here there's both a positive and a plus and a minus. That's just kind of what the conjugate is. It isn't something. A conjugate isn't something you guys got to really super stress over. It's just something for you to know, because there are sometimes when a teacher will ask you something like, oh, I have the number -1 plus I root 3, right? Give me the conjugate of that. The conjugate, of course, would be -1 minus I root 3. Now it would just be flipping the sign from positive to minus or minus to positive. And of course, this only happens when you either have I or a square root in your answer for the zeros. Coincidentally, we have both here, but it can just be one of them. All right. does anyone have any questions on finding zeros, anything that they were confused on? Just you can either just unmute yourself and ask, or you can just type in the chat box, and I'd be happy to answer them. Okay, I do not see any questions, so I will, 1 second, continue. There we go. Let's just take about 10 minutes to go through and let's do 8 minutes to work on numbers 2, 3, and 4 to just find the zeros for these 3 equations. Once you're done, put your answers in the chat box, and then afterwards I'll go over the answers to determine and see if they're correct or they're incorrect. And if you have any questions, of course, just put them in the chat box. So we'll take until 4:06 to work through these 3 problems. Just factor them and find the zeros. We'll take about 3 more minutes and then I'll go over the answers. All right, if you haven't already, just put your answers in the chat box, and I'll take a look at them, and I'll go over the problem. Alrighty. So I already went over the answer for number 1. I did it. For number 2, you would have plus or minus 2i, or plus or minus 1. Okay, and then for number 2, you would get 0, 5, or plus or minus 2i. And then for the last one, for number 4, you would get plus or minus 2, or I plus or minus I root 7. Yep. So those are the answers. Does anyone want me to go over a specific problem? I do not see anything, so I'll keep moving along. But if you do have any questions, just put them in the chat box. All right, moving along, we have this is another one I found on the internet. With great power comes great difficulty, factoring the polynomial. When I first learned this, it was a great struggle for me as well. Okay, so factoring polynomials. So this is the example that I will be going over. So f of x is equal to x to the 7th minus 2x to the 6th plus 126x to the 4th minus 252x cubed plus 125x minus 250. And then 1, 0 has been given. So this looks very, very daunting at first, but it's really about just breaking it down. So there are a few steps that to follow when trying to solve. So first, so what we've learned, so first, when the 0 is 2, of course, we know that it is x minus c. And then divide the polynomial by the given factor to find the quotient, factor the remaining polynomial until it can no longer be factored, and then solve for all zeros. Okay, Okay, I'll quickly go over this problem. So what we have is f of x is equal to x to the 7th, minus 2 50, right? This is the entire equation. Good. So this is the whole equation, right? And we are given the 0 of 2. Now, what does that mean? It means that this, whenever the f of x is f, when it is f of 2, the whole equation is equal to 0. So that means that there has to be the factor of x minus 2 within this equation, right? Within this entire polynomial, that there has to be this factor of x minus 2, or else without it, the statement wouldn't be true that there is a 0 of 2. So what we take this, right? We take x minus 2 and we divide it by the entirety of this equation. Yeah, and then so for this, I'm not gonna go over the entire long division process. I talked about that in another class, but you should do long division, or you can also do synthetic division. Either one works to solve for this, and then you simplify. So afterwards, you would get f of x. I'm gonna skip a few steps here. F of x is equal to x plus 5 times x squared minus 5x plus 25 times x plus 1 times x squared minus x plus 1 times x minus 2. And that would be the final factored form. It looks very ugly, but it is once you break it down bit by bit, it is a lot more solvable. So what we would do from here is, of course, set each of these factors to 0. These are, I would first personally take a look at these 3. These are the easiest 3 to factor. So for this, you would get the 0 of -5, -1, and our 0 of 2. Make sure when you are listing the answer, when you're listing all the zeros, to list the 0 that had been given as well. Make sure that you don't neglect that 0, that you don't forget about it. And then we use our good old steps of x squared minus 5x equal plus 25 equals 0, right? Get x squared minus 5x equals -25. And then you would take 1 minute. Yep. And then you would take x squared minus 5x. Remember, b over 2 squared. So 5 over 2 squared, 25 over 4 equals. I'm going to skip over all the steps because we're running a bit short on time. But in short, you would get 5 plus or minus 5i root 3 over 2. And then for this one, you would get 1 plus or minus I root 3 over 2. So that would be your final answer. The amount of, and then, sorry, not your final answer, but those would be all of your zeros. So once you found all your zeros, you just have to list them out: -5, comma, -1, comma, 2, comma, 5 plus or minus 5 I root 3 divided by 2, and 1 plus or minus I root 3 divided by 2. So when we take a look at our final answer right here, we count the amount of zeros. So 1, 2, 3, 4, 5, 6, 7 zeros, and it is to the 7th degree. So it perfectly matches up, which is good, and it means that we have found the correct amount of zeros. There's not one too many or one too little. Okay. Get back to share. These are the two practice problems. I would say for now, just do the first one. F of x is equal to x to the 5th plus 2x to the 4th minus 17x cubed minus 34x squared plus 72x plus 144. And then the given zero is -2. So we'll take about 8 minutes until 4:23 to work on this on the first problem. And then after you're done, just put your answer in the chat box. Of course, if you have any questions, just send them to me in the chat box while you if you have any questions while working through the problem, and I'd be happy to answer them. Okay, we'll take about another 2 more minutes and then I'll go over the answer. Alrighty, well, I'll go over the answer to number 1 now. Okay. So for number 1, the answer we would get. So first, you would factor it. F of x is equal to x minus 3 times x plus 3 times x squared plus, x squared minus 8 times x plus 2. So that would be what you get from factoring first. So after you have factored completely, you would of course find the zeros. So for the first one, the 0 would be 3. Next one, -3. For x plus 2, it'd be -2. And for x squared minus 8, you would factor that. You would simplify that, and you would get plus or minus 2 root 2 root 2, and that would be your final answer for how I got the 2 root 2 plus or minus 2 root 2. You would just set x squared minus 8 equal to 0, x squared equals positive 8, and then you would just square root it. Okay. And then for number 2, I'll just quickly go over it because I know some people finished number 1 and we're working on it. So you would factor it into f of x is equal to x plus 2 times x squared minus 2x plus 4 times x squared plus 6x plus 25. And then once you have factored it into that formula, you would solve for the zeros, and for the zeros you would get, so for the first one, you would get -2, and then you would get 1 plus I root 3, 1 plus or minus minus I root 3, and then you would get -3 plus or minus 4i, and that would be your final answer. Again, looking at the conjugates again, the conjugates are just, as you can see, the plus or minus in between the numbers right. I will quickly try to run through everything else. The binomial theorem, I think some of you might have seen this. This is Pascal's triangle. It's used to find the coefficients, meaning the number in front of the variable of the numbers in the binomial expansion. So this is this isn't something necessarily that you have to memorize, but this is just something that sometimes the teacher will give you like an empty sheet of paper and tell you to fill it out. This is just something good for you to know. It's pretty simple on how to solve how to find out the numbers. Everything on the two sides are just 1, and then every time the numbers converge, it is the sum of the two numbers. So 1 plus 1 is 2, 1 plus 2 is 3, so on and so forth. Like 6 and 15 is 21. So that is how you would create a Pascal's triangle from scratch. And the numbers here, the numbers running along this end from 2 all the way down, that is just the degree of the exponent. So for example, like x minus 1 squared, you would look in this column because of the 2. And then if you were doing x minus 1 cubed, you would look at this row. So that's just something, that's just another handy tool for you to keep in mind. So those are just the ways to use the Pascal's triangle. It's a way for you to quickly find out the coefficients. All right. And then these are just some practicing expanded binomials. Probably not gonna work on these right now because we are a bit short on time. But anyways, so those are just 2 problems. And factorials, I think most of you probably have encountered factorials before. It's just a little exclamation mark. So if n is a natural number, then x and n factorial or factorial n is equal to n times n minus 1 times n minus 2 all the way down to 3, 2, and 1. For example, if there was 10 factorial, it'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 0 factorial is just 1. We're not going to work on these. We won't cover these right now, but these are just some good things to know about expanding binomials and factorials. When you're expanding binomials, it is always good to reference the Pascal's triangle for it. It's a very good tool for you to use, so you don't have to, actually multiply like p plus r 7 times. Next, we're going to quickly talk about the r plus first term in a binomial expansion. So this is the equation. The r plus first term of the expansion of a plus b to the nth is n factorial divided by r factorial times n minus r factorial times a to the n minus r power times b to the r power. So for example, if you were to find, I'll just quickly talk about this example right here. So if you were given the question to find the 7th term in the expansion of x minus 2y to the 9th, you would use this expression. Let me find it very quickly. So it is the r plus first term. So instead of r, so for this, in this case, r would equal 6, n would equal 9, a would equal x, and then b would equal negative 2y. So then after you've deducted all of these numbers and what they are equivalent to, you would just very quickly plug it in and solve. And that will give you the 7th term of the expansion of x minus 2y to the 9th power. So that's just a very quick and easy way for you to figure out, oh, hey, what is the 7th term or like the 10th term or even like the 20th term? So that's just a very handy tool for you to use on tests. And there'll definitely be questions asking you specifically what is the term, and you'll have to remember this formula.